In this section, we're going to actually perform and interpret entire two-mean hypothesis tests using Excel for the calculations. So recall from our prior section, the formal hypothesis test procedure includes the steps of choosing your null and your alternate hypothesis, deciding upon the significance level alpha, computing the test statistic and the p-value. So this is the step that we haven't done yet. This is kind of the new steps, the meat of the problem really. And comparing p to alpha in order to draw your conclusion and interpret the results. And then I have a reminder of you of the different types of hypotheses that we can have, where we can have a two-tailed, not equal to alternative hypothesis, a right-tailed or greater than alternative hypothesis, and then the left-tailed or less than alternative hypothesis, and what those corresponding null hypotheses look like. Now, when we're doing a full hypothesis test, we also have to make sure that before we even get started, that we check the conditions to make sure that we are allowed to perform the test. So in order to perform the hypothesis test for the difference between two means of independent samples, there are different types that we could dive into, but we are going to only focus on independent situations. And these means are mu1 and mu2. And we are specifically also looking for where the population standard deviations are unknown. So again, we could do the known case, but that's so rare to actually know that information that we are just going to study the unknown standard deviation case. Then we have to meet the following conditions. The samples must each be random. That's usually given to you in the wording of the problem. It'll say a random sample was taken from here and another random sample was taken from there, and we can just take it for, its face value there, that they've told us it's random. The samples must also be independent from each other. Sometimes this is stated explicitly, and sometimes we have to just interpret that they are indeed independent. If they're taking samples of just these two different sets of people, we would have no reason to think that those people were in any way related unless we were specifically told that they were. I mean, if they said something like husbands and wives were surveyed, well, now I can see a very clear relationship between those people. That would not be independent. Knowing something about one spouse would probably tell me something about the other spouse. Or, maybe mothers and daughters, or different relationships like that. So those would be red flags. But for the most part, if they're just sampling two different groups, very likely these are independent samples. You also have to make sure that either both samples are at least 30, or that the populations are both known to be normally distributed. Either one of those hits that third criteria. As long as you hit those three criteria, then you know that you're good to go on and do these tests. And these are indeed going to be t-tests for specifically independent means, or independent populations, I guess we would say. And when we do this, we are going to be specifically in Excel using that data analysis add-in to perform these. This would be a good time to just double check. You should have, from back at the very beginning of the semester, put that on your Excel, downloaded that, basically that add-in. But if for some reason it's not there, then you would want to pull up those very first commands from the first unit and reinstall that if you don't have it. For our first example, we are going to open up the data set that I've shared with you that's called two-sample testing data. And the first tab under there should be called baseball versus soccer. So what we've got is two random samples of male college baseball players and then male college soccer players. The samples are both of size 30, so I can already start picking out some information here. We were told that both of the samples were random. They both hit the sample size of 30, and it says the samples were independently taken and randomized. So it reiterates randomized, but it also tells us that these samples were independently taken. So there's no relationship at all between these baseball players and these soccer players. They're just two random samples of those types of people. What we have is the weights in pounds of these sample subjects, and we're told that the population variations are not equal. This is another really important piece of information that you will want to pick out of your problems. You'll either be told that the population variations are equal or that they are not equal. And that is just a button, an option that you will have to choose or check whenever you go into Excel to perform this. You'll have to pick the correct one. So in this one, we'll pick the not equal variations option. We wish to determine whether the difference in the mean weights of all male baseball players and soccer players is different using an alpha of 0.05. And we're going to perform a full hypothesis test using Excel for our calculations. So again, I see that keyword different. It's going to lead me to my alternate hypothesis. So I'm going to write down H sub naught and H sub A. I'm looking for a difference. So I'm looking for, is mu sub, let's say B for baseball, different or not equal to mu sub S for soccer? And then my H sub naught then will be that mu sub B is equal to mu sub S. So we're going to assume that the average weights of these two different types of people are the same, and we're trying to show that they are different. So this is a two-sided test, and that will also be important when we go into StatCrunch. Or sorry, not StatCrunch, Excel. StatCrunch is a different program that we are not using. Okay, so I'm going to minimize this screen and bring up the Excel commands, because now we need to actually run this test. So I've already got the data in Excel, so check. We want to go to Data and then Analysis. So I have to arrow over because I'm only doing a half screen, but you should have Data, and then Data Analysis should show up as long as you have that plugin in there. And then there are all kinds of things we can choose under here. And what we want to choose, notice it says either choose t-test for two samples with equal variances or unequal variances. So this is where that unequal variances that was in our question comes into play. So we specifically have to choose that test here. And then we get our little box that comes up. We want to give the variable 1 range, so click into that box and then highlight your whole first column. Variable 2 range, highlight the whole second column. We always type in a 0 for the hypothesized mean difference, right? Because we always are assuming in our null that maybe there's no difference whatsoever. Maybe they're the same. Maybe the difference is 0. Because I do have labels as the top entry here, I have baseball and soccer here, I'm going to click the labels button. If you don't have labels here, then you can leave that unchecked. Double check your alpha value here. So alpha is defaulted as 0.05, but if I was given anything else, I would want to change that now, but ours was 0.05 in this case. Then go ahead and choose somewhere to put this output. I'm just going to click over here somewhere in the D column and let it work. Put this there and then hit OK. And sometimes it takes this a little while because it is a lot of work that your Excel is doing on the back side. And it tells us all of this information. So notice again over here in our Excel commands, it says you're going to read your test statistics, so the T stat, and also the p-value, but which p-value you choose is dependent on what kind of a test you were performing. So there's a t-value for a two-tailed, and there's also a t-value for a one-tailed. So you have to have noted what type of test you were performing. This one was a two-tailed test, So the two values that we're going to record are the t-value of this 5.8 number and this two-tailed p-value of, and notice how that came out, 3.32e negative 07. Okay, I'm going to bring back up my paper here so I can write some of this on it. And I'll just have to take it from over there because I'm not going to be able to make this so we can see both of those clearly. But what we've got then, I'll write it over here. We got a t-value of 5.805 if I round it to 3 places. And notice I'm going to write first what the p came out as, and then I'm going to edit that. So the p came out as 3.32e negative 07. What does that mean? That is scientific notation. So what that's telling me is that this number is so small that that decimal point really belongs 7 places to the left. So if I move that 7 places to the left, I will have 0.0000000, 6 zeros, and then 332. That is actually what the p-value is. Now, a lot of times they're going to ask you to round a p-value off to 3, maybe 4 decimal places. So if you get something this small, you very well may be typing in something like p equals 0.000. That's an acceptable thing to have to type in. Okay, so what we got here then is this very, 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 very tiny p-value. That is definitely less than 0.05. So since p came out less than alpha, we reject the null here. So if we reject the null, then we can say there is enough evidence to conclude that the mean weights of college, of male college baseball and soccer players is not the same, or is different, I could say there. Either way.